Hello student, today in this video we shall learn about prime factorization. Before that, let us review prime and composite numbers. A prime number is a natural number that has only two factors, 1 and the number itself. Look at these examples. The factors of 3 are 1 and 3. The factors of 11 are 1 and 11. The factors of 17 are 1 and 17. Here you can see these numbers have only two factors, 1 and the number itself. Such numbers are called prime numbers. A composite number is a natural number that has more than two factors. Look at these examples. The factors of 6 are 1, 2, 3 and 6. The factor of 14 are 1, 2, 7 and 14. The factors of 20 are 1, 2, 5, 10, 20. Here, all the above numbers have more than two factors. These numbers are called composite numbers. Now we shall learn about prime factorization. What is prime factorization? Prime factorization is to write a number as a product of its prime factor. There are two methods to find the prime factorization of a given number. 1. Prime factorization by repeated division method. 2. Prime factorization by building a factor tree. Let us learn them one by one. Prime factorization by repeated division. Find the prime factorization of 180 to express 180 as a product of its prime factor with the smallest prime number. Let's divide 180. As the number 180 is an even number, it is divisible by 2. You write 2 to the left of 180 and dividing it by 2 we get 90, which we write below the number 180. Now we divide the question 90 with the smallest prime number. As the number 90 is an even number, it is divisible by 2. On dividing 90 by 2, we get 45, which we write below 90. Now we have to divide 45 by the smallest prime number. As it is an odd number, so it is not completely divisible by 2. So now we move ahead to the next prime number, that is 3. Number 45 is completely divisible by 3. 45 divided by 3 is 15. Write 15 below the 45. Number 15 is also completely divisible by 3. That is, 15 divided by 3 is 5. Write 5 below the 15. Now we have 5 as the dividend. It is itself a prime number. So, lastly, on dividing 5 by 5, we get 1. Write the 1 below the 5. Now we have 1 as a quotient. Now we'll write the prime factorization of 180 as the product of all the prime numbers that we have on the left. Thus, the prime factorization of 180 is 2 into 2 into 3 into 3 into 5. So, we have to follow 3 steps while finding the prime factorization by repeated division method. They are: Step 1. Divide the number by the smallest prime factor. Write the quotient below the dividend. Step 2. Continue to divide the quotient with the smallest possible prime number till the quotient is 1. Step 3. Write the number as a product of its prime factor arranged in ascending order. Now let us solve one more example. Express 78 as the product of its prime factor. As 78 is an even number, it is divisible by 2. 78 divided by 2 is 39. Next, as 39 is an odd number, it is not completely divisible by 2. But the next prime number 3 can divide 39 completely. So, 39 divided by 3 equals to 30. Now, we have 13 as the dividend, which itself is a prime number. So, dividing 13 by 13, we get 1. Now, we have 1 as a quotient of 78 are 2 into 3 into 13. Now, let us look at the second method, prime factorization by building a factor tree. In this method, we break up the number into its factor, continuing the process till we get all the factor as prime number. Let us take one example. We'll find the factor tree of the same number 180. 180 can be broken up into many pairs of factors. Let us start with 18 times 10. Now, both these numbers are composite numbers. So, we again break them into their factors. So we can write 3 into 6, which will give us 18, and 10 can be written as 2 times 5. Here we get 3 prime numbers, 3, 2 and 5 as factors. We are still left with a composite number 6. Number 6 is formed by multiplying two numbers 2 and 3. Both these factors are prime numbers. Look, all the factors we have got are prime numbers. Thus, prime factorization of 180 is 2 into 2 into 3 into 3 into 5. This method too, we follow 3 steps. They are: step 1, write the given number as a pair of its factor. Step 2, continue this process till we get all the factor that are prime numbers. Step 3, write the number as a product of its prime factors and arrange in ascending order. Now let us solve one more example. Find the prime factorization of 99. We begin with finding out a pair of factors of 99. Kids, which pair comes in your mind first? Exactly, 11 into 9 will give you 99. Here 11 is already a prime number, but 9 is a composite number. It can be written as 3 into 3. 3 is a prime number. Now we see that all the factors obtained are prime numbers. Thus, the factors of 99 are 3 into 3 into 11. Let us take another example. We'll take the number 18 and we'll find the factor of this number using factor tree method. We split 18 into factors until we cannot split anymore. I'm using red for prime number and blue for composite number. I say to myself 18 comes from 2 times 9. I circle 2 as a prime number. I'll come back to it later. 9 is a composite number, so I split it down. I get 9 from 3 times 3. 3 is a prime number, so I circle both of them as well. I have no composite number left, so I have found all the prime factors. So the factors of 18 are 2 multiplied by 3 multiplied by 3. If you multiply 2 by 3, you'll get 6. 6 threes is 18. It doesn't matter how you split your composite number. You always get the same prime factors. Let us take one more example. We'll be finding the prime factorization of 48. I know 4 times 12 is 48. This time I have two composite numbers to work on, the 4 and 12. 4 comes from 2 times 2. 2 is a prime number, so I circle them and move on to 12. 12 comes from 2 times 6, and 6 is from 2 times 3. Circle all the prime numbers and no composite numbers are left. I collect all the prime numbers and the factors of 48 are 2 into 2 into 2 into 2 into 3. Isn't it interesting, students?